All right, so systems of equations. We will do it toward the end of the chapter. A system of inequalities, but we'll worry about those then. Things that I do want to point out as we start this chapter is one thing that I want to is as we go through this chapter, and to some degree, coming chapters. I don't feel like I give as much homework as previous chapters. We're really diving into some material. I'd rather want quality work rather than giving you a lot. I'd rather have you do really well on 5 to 6 problems rather than you struggle through 10. So you'll see and notice, it may not be super noticeable, but I do design these chapters that you do have a lot of homework. The first 5 lesson 1. Systems. It is in the last one where we will graph systems of equations and inequalities. Let's first give a definition to equations. It is a collection of 2 or more linear, I think you might a linear system, 2 or more functions or equations. Okay. Sometimes those so like chapter 4, the title of the chapter is like linear equations or something. So, one symbol that you will see me use to identify a system is a brace. Okay, you won't see the brace a lot like in the book, but when I make the quizzes or I make the tests, I will usually use a brace to identify. Here is my collection of functions. Okay. Now, since this lesson and the coming lessons are about solving, let's talk about the solution of a system. Okay. We're graphing 2 lines, and I am saying we can solve a system. What do you think a graph? I have 2 lines, and I'm saying we're solving this system. What do you think that means? What do you think we are looking for? What does it mean to solve an equation? Like chapter 2 type of stuff. Or even last chapter, solving inequality. What were we finding? Yeah, we were trying to find a value that makes the equation or the inequality true, right? You do Penrose and do that. So if I have 2 lines, and I'm talking about finding a solution to this system, what do you think I would be finding? with like a linear equation, we are finding x, what do you think it would be here? We are going to be finding where the two lines. You finish that. Yeah. Meet, intersect. So when we solve these systems, we are finding the lines intersect. Now, we will talk about it today, so I'm not going to spoil some of it. Okay. So in this lesson today, we're going to be doing some graphing. Now, here's the nice thing. When we're graphing, the majority of the time we're graphing slope-intercept form. Okay. Example 1. Solve the system. I don't feel like I want to write by graphing, but just so we know. So there's my system. y equals 2x 4, y equals x plus 2. We will replace. Let me see. We learn 3 to 4 different ways to solve these. So let's graph. That very first one, y equals 2 plus 4. What's the first thing I'm going to do when we graph slope-intercept form? Yep. So the y-intercept 4, 1, 2, 3, 4. And then what is the rate of change of that function? It's not 4. Yeah. So up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, up 2 over 1. Okay. So there's the first one. There's the first line. And then what about the second one? Where am I going to plot that y-intercept? Moving, it is at 2. That rate of change is 1. So down 1 over 1, down 1 over 1, down 1 over 1. Here's something very important about this lesson on these notes. When you do this on paper, make sure your scaling on the graph is correct. If you are using graph paper and you're not using the blocks, your answers are going to be very hard to find. It's going to be inaccurate. Okay. So please use blocks. That's what they're there for. So we've graphed each of our lines. Where do they meet? Where do they intersect? Yeah. partially yes. When we give a solution, we will always put the point. So it is -2, 0. What it tells us which values work for each equation. So in some ways, this is kind of like an and statement because I'm trying to find the points that will make both of these equations true and equal. Okay? So example. Al, the alligator, 2 L's, is born at 4 pounds and grows 2 pounds a week. Stan, the alligator, we'll supply that, starts at 2 pounds and grows 3 pounds a week. Write a system to find when their weight is equal. All right. So what's important to recognize is that when we write these equations, we are going back to chapter 4 and writing linear functions based on the information they are given that they give us. Okay. So, step 1, the system. So we're told that Al is born at 4 pounds and grows at 2 pounds a week. How would we write that as a linear function? Yeah. Yes. Yes, you're thinking about the graphing, which is good. It will be y equals 4, where you start, plus 2x. That up to over the weight of Stan B. How would we create that model? Based on what we're doing. One thing that's also worth pointing out is that with these, the second one will follow suit. Go ahead, Damien. Yes. So there's now I will graph. Okay. So I'm going to do that very first. And because I've just got a smaller area, I'm going to count by 2's. So 2, 4, 6, 8, 10. So this one starts at 2. Sorry, this one starts at 4, and I'm going up to 1. Up 2 over 1. Up 2 over 1. Up 2. Okay. So there's my first sign. That's Al's weight. Okay. You can do these in different colors if you want to as well. Just a little late to the game to start adding it. Then the second one starts at 2, but then goes up a week. So that's going to be 2 to 5 over 1. So there's a point at 5. And then up 3, 1, 2, 3 over 1. So 2, 8. And then it's going to be 3, 11. So based on our graph, when is their weight the same? As we read the graph. Yep. At 2 weeks, they are at 8 pounds each. Good. One thing that's important to recognize is that you will do high learning this year for math. But even when you think about standardized testing, like in the future, it's important to recognize reading graphs is really important. Whether you're dealing with math, whether you're dealing with science, dealing with graphs, being able to read and interpret them is really important. This is just another one of those instances where we have to understand context. We have to understand what is the problem asking us. So, one last thing to talk about, and one more example will be done today. We can classify systems. Not so much into like, this is true, like linear systems and nonlinear systems. But we can classify systems based on the types of answers that they have. The first classification is called an independent system. Okay. An independent system is a system that has one solution. Okay? So, like example 1 is an independent system. We get one solution when the lines are different. Okay? We can say type, number of solutions, and then the type of lines these are. Okay. Solutions. Okay. What do you think would be the opposite of an independent system? Yeah, dependent. Now, the dependent system has infinite solutions. What kind of lines would we be graphing if we have an infinite amount of solutions? Yes. Rather than say it appear as one line, but these lines would be the same. Because one thing that's important to recognize is that we can write slope-intercept form and standard form and point-slope form. So we can see the same graph just in different ways. Okay. Now, these two types of systems are also called consistent systems. Okay. So like in the homework, they'll ask you if it's like, okay, what type of solution do you have? I would say that's in the solution because it's, yeah, no solution. Do we have a case where there are zero solutions? What type of scenario would it be if there are zero solutions? What type of line would it be? Yeah. Because those lines never touch. These are called inconsistent systems. Inconsistent systems. Example 3. System that you will want to with graphing in this chapter is standard. So slope intercept form and standard form. You will not see points in this chapter. So, all right. So let's graph the very first one. What is the y-intercept of y equals 2x minus 3? Yeah, go ahead. Yeah. 1, 2, 3. So I'm going up 3 over 1. Up 3 over 1. I could even go down 3. What kind of, and then what do I use to graph standard form? Graph standard form. No. How do we graph standard form? Yep. So cover up method. Cover up the x. Y is negative 3, which is right there. Cover up the y. The x is 1, which is right there. These are the same line. So this is consistent and dependent. Dependent. One way to remember like what's independent and what is dependent is that to depend on like leaning on someone. They're the same. So in a system where there is a solution, they're like that. 15 minutes left of class. Your homework today is 11 through 25 odd. Next semester. It's page 338 and 339. Okay. 338 and 339. Alrighty. You have to do this on graph paper. Alrighty.